Ladies and gentlemen, welcome to scientific notation. Let's go ahead and get this going. So this is kind of, again, like one of those older topics that I figured might as well teach you. Okay. So scientific notation. Have y'all ever like taken, I mean, you could take like a huge number, right? Like maybe like, I don't know, 450 times, I'm just going to put like 1 million, like so many zeros, right? And then in your calculator, you get this huge number, right? Or you could actually make it a really small number. This is actually called scientific notation, and that's what we're going to be talking about today. This is how the calculator represents it, and then there's a way that we're going to be representing it on paper. So let's first go over here, kind of like fast forward. All right, there is our teak. And we are going to not only be expressing numbers in scientific notation, but taking scientific notation and going to standard form, along with doing some multiplication and division with it as well. So the first thing I would like for you to write down is the definition of scientific notation. The definition of scientific notation, which is a number in scientific notation is expressed as a, so there's two parts of it, a times 10 to the power of n. So today we're going to be figuring out what a is, what n is, where a has to be a number that's between 1 and 10, and n is an integer. Okay. When your pencils are down, I'll know that you're done writing down the definition. Alrighty, and so some examples of that might be, maybe you have something that looks like this. Let me get this going here. Maybe you have something that looks like this, 5.4 times 10 to the power of 3. Or you could even have something that looks like this, 2.03 times 10 to the power of negative 5, okay? This right here, when you have a positive exponent, usually represents a really big number. And when you have a negative exponent, it represents a small number, okay? So those are the equivalents. Let me go ahead and go right here. These are the 5 steps. So step 1, we move the decimal point until it is to the right of the very first non-zero digit. The result is the real number a. So here we search for a. A is equal to what? So I'm going to give you a little example here while you write down the stuff. Let's say I start off with this number 2035. Okay. So if I move the decimal to the first, until it is to the right of the first non-zero number, the first non-zero number is right here, right? And I'm going to move my decimal to the right of it. So I originally started here and I moved over here. So a is going to be equal to 2.035. That is the value for a. That's step 1, find a. Okay, so step 1 was to find a. Step 2 is now we're going to find 10, okay? Because remember, we're kind of going for this. So we're going to find n, which is the exponent for 10. That's what I meant. So we have n. Now remember, if we start off with a big number, then it's going to be positive, okay? And so when we look at this, we looked at our original number. We ended up having to move it to the left 3 times, okay? So when we move things to the left, and I think that was what when we move it to the left, we know we're going to have a positive n. When we move things to the right, we know we have a negative. I prefer to think about it, did I start off with a big or small number? So here I start off with a big number. That means that my n is going to have a positive 3 as its value. Okay, we moved it 3 times to the left. And so then when I finally write my answer, It is 2.035 times 10 to the power of 3. Okay. This is scientific notation. And then there might be where you need to remove any unnecessary zeros, that type of thing, okay? But here we do have a 0, but it is necessary because it's sandwiched in between two non-zero. They're usually only at the end or at the very front. Okay. Let me know when you're done writing the notes, the steps, 1, 2, 3, and 4. All right, ladies and gentlemen, let's go ahead, go to our first example here. We're going to express this number in scientific notation. So our first step was to identify what A is, right? Let me talk to Ariana. Can you tell me what is my value for A going to be? Go ahead, I'm so sorry. It is 4 point, but it's got some stuff after it. And then these are actually considered unnecessary, right? So I'm going to leave them off. Okay. So A is equal to 4.02. Anybody have any questions on how she got that? Okay. So when we look at, we put the decimal there. The original decimal was here, right? So I want to calculate what N is. First of all, because N, this is originally a very big number, is N going to be positive or negative? Positive, because it's a big number, okay? So if we start with big, then N is going to be positive. If it was a small number, then N is going to be a negative, right? Okay, Emma, can you share with me, what is my value for N? Let me know if you need a hint. Okay. Are you there, Emma? All right, Fabian, can you help her out, please? Let's see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, I would agree with 12. Good job. Okay. And so when we put it together, we have 4.062 times 10 to the power of 12. Now, I just kind of want to point out in your calculator, the calculator doesn't say times 10, they just actually put an E there. And then your exponent is right there. Okay. Any questions? So ladies and gentlemen, this is scientific notation and it is equivalent to this number right there. All right,
where did the 10 come from?
Where did the 10 come from? Basically, you know how like when you multiply anything by 10, like if you have 2 times 10, right? You get 20. So in essence, you just moved over that decimal one place to the right. You just kind of whoop, added a digit. You moved the decimal to the right. So that's why 10. And then 10 is when you multiply by 10 to the power of, this is telling you how many times you're multiplying by 12. So does that kind of make sense as far as the 12 tells you how many times you're moving the decimal?
Yes.
Okay, cool. All right, so let's look at this next one. We're starting off with a very small number, okay? 1, we need to figure out what A is. 2, we need to figure out what N is, and then we're gonna write it out, okay? So let me talk to you, Jack. What is my value for A? What's my first non-zero number? 8. Then we put a decimal, and then we write everything else that we need. Did we need all these zeros in front anymore? No, we did not. Okay, good. So now I have my new decimal right there. Let me talk to Jessica. Can you share with me, what do you think N is going to be? Keep in mind, we start off with a very small number, right? -7, let's see. That's 1, 2, 3, 4, 5, 6, and 7. Good job. And so when we write that out, that's going to look like this: 8.23 times 10 to the power of -7. So anytime you see that negative number there, you know you're probably dealing with a very small number, okay? Let me know if you can't read my writing. I'll be happy to rewrite it. Any questions? Okay, so your turn, okay? In the chat, I want you to go ahead and tell me A, B, C, or D. So we're going from standard scientific notation to standard form, which I think is pretty easy, honestly. If I was to remember one thing, if n is greater than 0, then we move it to the right. And if n is less than 0, we move it to the left. So that's basically just saying if you have a positive n, you move it to the right. If you have a negative n, you're going to move it to the left. I still personally like to just think of it, if it's negative, it's a little number. And if it's positive, it's a big number, and you make it a big number, okay? And you can insert zeros and decimals and commas as you need it. Does anybody need time? Okay, I will pause. All righty, let's get in this. I'll show you. So I got a positive 5. Is it going to be big or small? Big, right? So let's make it big. I'm going to take this, and I'm just going to move it 5 times to the right, because that'll make it big, right? 2, 3, 4, and 5. Let's put in some zeros to hold all those spots. And ladies and gentlemen, and you can toss in a comma. You can put in a decimal if you like, but that essentially is this written in standard form. Got it? Easy? All right, let's look at this one. I'm going to start over here. Big or little? Little, because it has a negative exponent, right? So we're going to make it little. That means that we're going to move it to the left. 1, 2, and 3. There's my new decimal, and I got a 0 and I got a 0. So you could write it as, or you could write it as, and we're done. Questions? Anybody need more time to write, or you're good? Okay. So I want you to try it now. And pause. All right, ladies and gentlemen, now that we've got a hang of, how to write it in scientific notation, go between standard form and scientific notation, I'm going to talk to you about how to evaluate. Evaluate, of course, means that they want a value at the end, right? So we are multiplying, and notice how this x also means multiplication, yes? So essentially, this is the same as 5 times 10 to the power of -6 times 2.3 times 10 to the power of 12. Does anybody happen to know, I mean, we didn't really cover it too much this year, but what property tells me that I can multiply things in different order and it doesn't matter? Maybe from way back when? Because 3 times 6 is the same as 6 times 3, right? So I can actually rewrite it so it's a different order. If you didn't know, ladies and gentlemen, it is commutative. Yes, that is the bright side, Philip. All right, so this is called a commutative property, where you can basically reorder things. 5 times 2.3. Let me put it in my trusty handy dandy calculator here. 5 times 2.3, and I have 11.5. Okay. And does anybody remember, what do we do with our exponents here when we're multiplying? Add them. -6 plus 12. Good, Sonia. So we can actually end up with 11.5 times 10 to the power of 6, +6. Okay. So there's a couple of ways. One, you could expand it out, right? And move that 6 times. It's positive, so we want a bigger number. 1, 2, 3, 4, 5, 6. And then bring it back in, right? And you could say, well, you know what? I really need the decimal right here. A is going to be 1.115. And that means that I'm going to move it 1, 2, 3, 4, 5, 6, 7. So that's 1.15 times 10 to the power of 7, right? That's one way. You could do that. But you could recognize, hey, you know what? I'm right here. This is the same as this. And I just need that to move over 1, right? And if I'm going to make it move over 1, then I'm just going to add 1. And I end up with 1.15 times 10 to the power of 7. Do y'all see that? Because you're starting off with technically a big number and you're making it smaller, so it's going to have a positive 1 exponent. Either way, whatever floats your boat, whatever works for you. Questions? All righty. Can I move on? Let's go ahead and try this one. About division. So if we add our exponents when we're multiplying, what do we do with our exponents when we are dividing? Subtract. Okay. So basically, we, everything here, we can just say 4.5 divided by 1.5. Well, that's equal to 3. I put that in my calculator. And then I have the 10, right? 10 over the power of 8 and 10 to the power of 10. So 8 minus 10. I end up saying 8 minus 10. And I get 10 to the power of negative 2. So I'm going to put that right there, 10 to the power of negative 2. Which means, am I going to have a big number or a small number since I have a negative right there? Small number. Let's make it small. We're going to take 3. There's my decimal. We're going to move it 2 times to the left. 1, 2. And plug in a 0. So standard form looks like this. 0.03, right? And scientific notation looks like 3 times 10 to the power of negative 2. Please keep in mind that in your calculator, you will see it as 3e negative 2. That's how they would write that. Questions? All right, your turn. Now this part may seem kind of baby easy and, I don't know, but I'll just show it to you just in case. 1,000. That implies 1,000, right? Otherwise known as 1 times 10 to the power of 3, right? And notice how the exponent of 3 corresponds with the number of zeros, yes? If I have 1 million, that's 1 times 10 to the power of how many zeros is 1 million? 6. If they said billion, what would my exponent be there? 9, okay? Just think of how many zeros you have now. So when you're rewriting this, okay, just to kind of show you, when you could say 400,000, you could say 400 times 1 times 10 to the power of 3. Okay. And that is, of course, the same as 4 times 10 to the power of 2, right? 4 times, let's see if I can make this like above here. Oops, sorry. My bad. Hold on 1 second. That's a 1. 1 times 10 to the power of 3. And so when you do that, that's 4 times 1, 4, and 10 to the power of 5. You see that? And then you can just put 5 zeros on there. 1, 2, 3, 4, 5. 400,000. All the same. Okay. You could also have, do a little different color, 15.4 million. Okay. You could have 15.4 times 1 times 10 to the power of 6. which this is, of course, the same as 1.54 times 10 to the power of 1. And this is 1 times 10 to the power of 6, which should get you 1 times 1.5 is 1.54. And we have 1 plus 6, 7. And you could write this moving the decimal 7 places. So that's 1 place, 2 place, and you're going to need 5 more zeros. 1, 2, 3, 4, and 5. And that would look like this. Comma, comma. That would be equivalent to 15.4 million. So all ways that you can write this. Okay? Questions? All right, guys. So I'm going to go ahead and show you an example, see if you can do it. Thank you so much for joining me today. We're in the final stretch. Remember that you absolutely must show up during the time for our final exam in order to know whether or not you are exempt. All right. Take care. Have a good one. Bye-bye.